I'm going to talk about education, and 20 minutes is a short time for that. It is a matter of whether we understand the substance of Green Deal and the substance of climate. There are some statements in my presentations and also quotations from literature for those who would be interested in looking at them. What we want to do now is to look at the system of sun, water, plants, water circulation, climate. We looked at the knowledge of students of the first year of biology teaching, and we asked how much they know about photosynthesis, how much biomass, how much photosynthesis is absorbed by biomass, and only 10% of students knew. And also we looked at primary school pupils, and we discovered that they have very little knowledge about water. And we also published the results of this research, this survey. People in the past used the shadow of trees. Nowadays, children are cooling themselves in supermarkets. And to eliminate that, we produced textbooks for schools. And we also started a project which is called Education for Plant Literacy. And it is a project in which 6 countries are involved, and the textbooks will be published in the relevant languages. If we want to understand climate, we need to know what the sun is doing. The sun is heating up the earth by 290 degrees Celsius, and during a sunny day, up to 1,361 watts per square meter reach the Earth's atmosphere. And farmers actually are managing a vast area of land, and therefore they are the key factor in how the climate will develop. If there is alfalfa or some other crop on the land, water evaporates, and this requires 2,400 kilowatt. If we stop that, if we get rid of the soil, this energy rises up in the form of hot air. Here in the meter you can see a radiometer. Then you can see the red arrow, which is the hot air, and this device measures also the flux of the hot air going up. We then use the net radiation, and only a small amount goes into photosynthesis. It's just 1%. And we decide by that how much land we will have, whether it will be dry or wet, and whether the solar energy will go into water evaporation, or whether the surface will heat up and hot air will be rising. Here you can see what happens a sunny day during the summer solstice. The red line is the incoming solar energy, the blue one is the reflection, the brown one is the flux of heat upwards. When it's overcast, you can see that the red line is even 10 times lower. So the cloudiness decides on the amount of incoming solar energy. What is interesting here is that when there is a clear day, sunny day, The blue line shows the temperature of the skies, which can be down to -10 degrees Celsius, and the green line shows the temperature of the grass. When it's overcast, these two temperatures are close to each other. But then there are days with cold air coming. That was March 2022, when the effective sky's temperature was -30, -40 degrees. So water vapor decides about how much sun we will get, and whether the sky will be cold, which means the greenhouse effect. Here you can see a table of the amount of solar energy. In 2017, there was 8.2 kilowatt, and 31% of that was radiated back into the sky. So and you can see, when there is no water in the air, that's the end of the winter, the skies are clear. We receive 5 kilowatt hours, and 59% is radiated back to the skies. This is the greenhouse effect. You can see that the concentration of CO2 does not play a role in it. If we do not have water in the air, crops freeze. This is blueberry bush, which got frozen in March 2022, for example, where farmers were complaining about their crops being frozen as well. And this is the question, whether humans influence the amount of water in the air. There is an expert opinion on the climate which says that the atmosphere heats up the Earth actively, which is in contradiction with textbooks, and we wrote about that to the president of the Academy of Sciences, and she refused to deal with it. But this actually refutes the statement that CO2 is decisive. The key is how much water we have in the air, in the atmosphere. Looking at the agricultural landscape in summer, when it's sunny, you can see different types of land, forest, agricultural land. The temperature is below 30 degrees, and when we cut that and there is no crop, it's overheated. And you can see a dry meadow, for example, without water, and then the temperature is 40, 50 degrees. If you are a pilot and fly a plane, you know that the rising hot air pushes you upwards. So let's remember some basic physics. Solar energy flux is measured in watts per square meter, and the solar energy reaching the land can be up to 1000 watts per square meters. But we need energy, we need latent value, which is somewhere around 700 watt, which is the capacity of your car battery. And 1 liter of water absorbs the energy of 0.7 kilowatt hours. So 1 liter of water, how much vapor does it produce? It's 1200, and this is the principle on which a steam engine works. And if so, the key thing about energy is that water vapor is the key thing that influences the climate. because water vapor rises or gets condensed in the form of fog, and it then prevents surface freezing on the surface of the land. Vegetation. When there is sun, we measure the amount of solar energy, 877 watts per square meter, and the surface temperature is 51 degrees. But in the shadow of a tree, the amount of solar energy is 10 times lower and the temperature is 25 degrees lower because the tree evaporates water, and we can measure that. If it evaporates 25 liters per hour, then the tree cools the air down with a capacity of 14 kilowatts per hour. And this is basic knowledge, which, however, is worth a lot. If we have holes, built up areas, and there is sun, what we get is the red arrow. But if we have cultural land with water, soil, crops, then the solar energy is absorbed by the evaporate, and then it is absorbed in biomass. And this is the proper literature if you want to look at it. So to be able to understand the climate, we need to know that photosynthesis absorbs several watts per square meter. But on the other hand, biomass is important because it cools down the air, it supports water cycle, water circulation, and there's a mean value 100 milligrams evaporated, and for that we need 240 watts. So if we drain 1 square kilometer and we thus destroy the soil, then if there's sun, we have 240 megawatts of energy. If if our forests in Šumava die off because of the bark beetle, the temperature goes up, and the rising flux of hot steals water from the neighborhoods, and it goes up. And if the temperature is too high, we have no clouds. If we have a live forest in the treetops, the temperature is 24 degrees, but down the forest retains the water, then water is evaporated, a cloud is formed, and then the water goes back down. If the forest is overheated, we have just hot flows of air going up. In history, civilizations were drying out. The overheating is the result of loss of vegetation, but this is not part of the area assessments. An example of that. It is a very apt example because it concerns an area close to Prague, close to D1 highway. The total area is 2,500 hectares, and according to the European Information System Current Land Cover in 1990, the area of paved surfaces was 300 hectares. 28 years later, it's 730 hectares. So between 1990 to 2018, 430 hectares of built-up areas were added. This is a satellite picture from 1985 and 2023. My colleague Mr. Vopravil showed similar pictures. So what does it do to the climate. This is a landscape cover. The red areas are additional residential premises, which are drained, of course. And so those 430 hectares on sunny days were cooled by evaporation as farming land, but now we generate 0.4 to 1.3 gigawatts of heat. What does it mean? When we lose 11 hectares of farming land daily, the municipalities would like to have arguments. They do not have the halls, the industrial zones, because they are aware that the climate is damaged in this way. They are aware that they lose water for the further additional production of food, and they are aware that we are creating more heat. This is additional information what happened during the 28 years. Czech Switzerland, the forest dried up because no action was taken against the bark beetle. And then there are further principles. If there is a dry surface and it's a period of drought, of course the dry area is not to be blamed because there is no water, but the dry area is overheated. The red arrow shows the hot air going up, being extracted from the forest, and also water is lost in ponds and lakes. This is evaporation due to which we are losing water. Now some examples of relevant literature, but now let's have a look at average temperatures. I'm showing it to demonstrate how the input of solar energy is rising. This is air temperature at the level of 2 meters from 2009 to 2023. There is 1 degree increase, and the solar energy hitting the ground, it means the average influx of solar energy, there's an increase from 125 to 140 during the 14 years, and down you can see the influx of heat in temperature and in the soil. But the greenhouse effect is going down. How come? Because the Green Deal is based on the increase of CO2 concentration and methane concentration. This is why the allowances were introduced, but looking at these graphs we can see that the greenhouse effect is going down. The greenhouse effect, the radiative forcing, between 1750 to 2000 was 1 to 3 watt per square meter, but we are getting more solar energy during the last 10 years, more by 5 to 10 watt. How come? These are measurements showing the years 61 to 2021, and it's the sunlight duration. We can see that the periods of sunlight are longer. We have more solar energy. This is expressed in megajoules, and we can see the growing solar energy input since the 1960s or 1980s till now. In in Poland, in Czech Republic, in Europe. What is the cause for that? The skies are getting clearer. This is proved by satellite pictures as well, because the solar and energy reflection is lower. Sometimes the clean atmosphere is blamed because of having less contaminants, but the increase continues. The growth of average temperature in Czechia is higher than uh, uh, the increase globally, and in some drained areas it is even higher than that. So the temperature of air is growing, the solar energy is growing, we have higher temperature in the atmosphere, and this shows that we have less water in the air. This demonstrates what happens to the vegetation, or how it affects all this. There has been a surveying monitoring how rains are proceeding from the coast to inland. So where there is no vegetation, hot air is created, it rises up, and as you know, water is evaporated over forests, then clouds are created, and then it condensates, there is rain, and again water is absorbed from the sea, from the oceans. At the second UNO water conference in March, our colleague from Slovakia, Mr. Kovács, presented a white paper. And there they said, please, let's go into the fields. We need more vegetation, more water. And by that, we will create conditions for the accumulation of organic matter in soil and for a better water cycle. This was noted by FAO, the Organization for Agriculture. Martin Kovács has visited them frequently, and I hope this will continue, even though he has a position in the government now. Not to repeat the same mistakes prior civilization did, we need to explore the things. I asked some people when their land, their soil dried up, and they said it happened when we drilled wells, and it happened in history as well. But there are some positive examples. Our Slovak colleagues visited Darevady. There was 1,500 hectares of drying land. People moved away, and there was a mission of Hermann Bacher. They explored water retention then. They improved the situation by certain measures, and they were able to revert the drying. This is an international white paper I am referring to on this slide, but what we need is water evaporation. For that we need vegetation. We need to improve knowledge of solar energy and water evaporation, because people need to know where errors are made. These are buildings of an entrepreneur who has a building company, and you can see he kind of ramped these buildings with vegetation, and this improved the situation locally. And I would like to appeal that you come and see this, because the key mistakes we do, for example, is when we cut vegetation and pave the surface with concrete. Farmers from South Bohemia visited Italy, where there was a history when they drained the coast, and they started growing normal crops. They increased irrigation that was insufficient too, so they switched for foil houses, not to lose water due to evaporation, but this is bad. Here on the left, you can see a situation. From the inland, we are looking at the coast. We can see the clouds which cannot enter the inlet because there the hot air is going up and doesn't allow the clouds to enter. This can be proved by pictures taken from airplanes, but these are the basics of land management. Ponds, we do not lose water because of ponds. Ponds help us retain water, and also they are positive in terms of biodiversity. So we need to understand what solar energy does, and we need to have water, because there could be even more sunlight. Our average temperature is 9 degrees, but in addition to that, we need water. So thank you for attention.